We're looking at what happens in the calculator behind the scenes whenever you do a binomial PDF, along with a few other things that we're going to be looking at, do a little calculator training. All in all, it was a fairly quick lesson because I found a way to kind of shortcut it. So I'm going to continue that fine tradition right here on this video. So keeping in mind that, we talked about binomial settings, and we brought up the idea of having 2 girls out of 5 births. Well, remember that that could happen on the first 2 births, the last 2 births, the first one, the last one, any number of combinations. I think there are actually 10 ways that can happen. So yes, we are accounting for k successes among n observations, which is combinations. Remember this from way back when we started doing probability? Now, you still don't need to know this formula, right? That's not a big thing. But you have to recognize that this is combinations of so many things taken so much at a time, like 5 kids taken 2 at a time for a number of girls. And we'll just let the calculator worry about all the factorials and things like that. So that's going to show up in your binomial formula, which is this. Here it is. So it looks a little intimidating. It's actually very easy to memorize. Let's just look at it. This is the probability that x equals some particular value, like 2 when you're talking about 2 girls out of 5 births. All right, n is your number of trials, k is the number of successes, p is the probability of success. That's going to be raised to the k power, same k as this, and 1 minus p is failure. It's the probability of failure, and that's raised to the n minus k power. So this is what your calculator does behind the scenes when it's doing a PDF calculation. In fact, if it's doing a CDF calculation, it's doing a bunch of PDFs and just adding them up. So this is how binomial works, and it's just taking into account how many outcomes could represent the particular event you're talking about, times the probability of success, times the probability of failure to certain degrees. So here's an example of it. 10 free throws, so n is 10. 80% free thrower, so p is 0.8. Here's the shorthand for it. What's the probability of making 7 shots? All right, 7 is going to be your k. So probability that x is 7, 7 out of 10, right? 10 things taken 7 at a time, times the probability of success raised to this power, times the probability of failure raised to the power of the difference of these two values. It's very easy. We're going to do a sample one to end the lesson today, so stand by for that. All right, we've already seen mean for a binomial random variable. Remember, mu equals n times p. So if you're an 80% free throw shooter and you throw up 10 free throws, you would expect to make 8 of them. That's 10 times 0.8. Now it also has variance, all right? So that's n times p times 1 minus p, standard deviation, because you'll really never be dealing with variance for binomial. It's just going to be the square root of that. So there it is. And if you ever do need variance, just take the radical off. Now, if you are a person that reads the book, and I think those are maybe a little bit few and far between, but our book and then many others will use this letter Q to represent the probability of failure. So you may see the square root of n times p times q, which is the same as this. It's just a different kind of notation. So here's an example. 80% free throw shooter. Seems like there are a lot of them going around. N is 10. So the mean is going to be 10 times 0.8. And the standard deviation is 10 times 0.8 times 1 minus 0.8. Square root of that gives you this. And what we're talking about is, like, if you imagine making probability histograms out of this, some will be more spread out than others, right? So that's what we're talking about when it comes to standard deviation. All right, this last point is just to re-emphasize that if you get a mean for something like free throw shooting, and it turns out that this number has a decimal like 8.2 or something like that, please don't round it, because that's not an actual event. An average is not an actual event. It's a snapshot of what you would expect your average event to be, your average, total outcome. And so if it's 6 or 8.2 and you round it to 8, well, it's a little closer to 9 than 8, and that's not the actual mean. Okay, so you want that much detail, even if it doesn't match up to something discrete. All right, so we're going to go to packet page 3. So let's get out of here, and we'll go straight into that. And so I've set it up. All right. It was really kind of funny because I did ask every one of my classes to list the 4 rules for a binomial setting. And look, I do understand you prepared for your test, you did your project. The last thing you're going to do is throw in memorizing your 4 rules for a binomial setting. And it's no surprise that no one practically could do it. All right. So I will do it for you. There are 2 outcomes, success or failure. So let's put that there. So 2 outcomes, success or failure. Let's see, probability of success remains constant for every trial. Oops, down the wrong letter there. Let's just say is constant. All right, so I guess that's a sentence. That's kind of a sentence too. Every trial is independent. And lastly, there are a fixed number of trials. Or there is, I suppose, there is a fixed number of trials. Okay, so you need to commit those to memory. You need that. You need the formula for calculating binomial PDF. You need the formula for mean and the formula for standard deviation. So these aren't tough, but at some point we need to get those down. All right. Now, we also moved on to this problem. And in the past, I have had them draw, complete probability histograms with titles and labels and scales and nice, neat, straight classes and all that kind of thing. I thought, you know what, we have been working hard. We're just going to do this on the calculator and, just kind of learn some quick calculator things. So let's go on to the calculator then. All right, so here it is. Make sure if you're doing along with me that you clear it. And we're going to work with pages so that you can, this is actually a little bit of calculator training too. And we're going to show how the pages link up so that we can change some of the items that we've input and then have it just roll throughout the pages. All right, so we'll start out with a spreadsheet, and just like any random variable, we'll call this X. And we do need the numbers since according to this, if we can look at it, here it is. We have 8 free throws from a basketball player shooting them. And we want probability histograms for first a 20% success rate, then we'll change it to 50, then to 80, and we'll just look at the impacts that it has on, drawing histograms and means and standard deviations and whatnot. So we do need the possible outcomes for shooting, and these will be makes, so we want from 0 up to 8, all of those discrete values. And maybe tomorrow I will show you how you can do these things the quick way. Although putting in 8 or 9 numbers here isn't really that taxing, just a little boring to watch me do it. Okay, so let's scoot over, and we need to set up this next column for probability, and I think I'm just going to call this P. You can call it PROB. That's normally what we do, but something simple would be fine. Okay, I am going to leave this on the formula because what I want to do is put in every single binomial PDF for all these x values. And I want the calculator to do it for me all at once, right? So if we're going to put in a formula, we need to start with equals, and we want binomial PDF. So if you go to menu, it's a little bit reduced in size, but if you go to statistics, you can open up distributions, and here's binomial PDF. So you need to choose that. Oh, that came out funky. How did that happen? Oh, it's behaving. This is live TV. Here we go. So what was that? Let's try that again. All right, so statistics, distributions, binomial PDF. Okay, that's what we want. All right, so 8 is n, and we're doing the 0.2 version first. And when you go to the x value, we want to just put the letter x in there because we have set up a whole bunch of x values, so why not include all of them? Go ahead and hit OK. And then if you hit enter again, it's going to want to know column reference. In other words, we're referring to the A or the B up here or to the variable. We want the variable, right? So right arrow, go down, pick variable, enter, and then go to OK. And there they all are. Surprise! So let's go ahead and now go back to the home screen and set up a stats graph. Here we're going to add x to the horizontal because that's what the x-axis typically is, but don't add probability here. You're probably not remembering, but remember we went to menu and plot properties and we added a y summary list. Remember that? Come on, I'll pick it. And then we can just go ahead and pick either one of these two. We want P, and there it is. All right. Now we're not going to draw that, but we will describe it. It will be skewed to the right. So let's just go back here, and we can just write in here instead of writing the whole thing, drawing the whole thing. We'll just put skewed right. And while we're at it, let's start filling in number 3 here. They want the mean and the standard deviation. All right, so we can do that. So here's the mean. Remember, that's n times p. Well, in this case, n is going to be 8 and p is 0.2. So that's 1.6, right? And if we go back here, it should come to as no surprise, although these should actually be numbered in the middle. Like this should be the 1, and this should be the 2, and this should be the 3. Anyway, at 1.6, we're talking about being like right here in this class, and you notice it's the tallest one, so that makes sense. And the rest of it just tails off from there to the right, okay? So let's finish this up, and we'll do the standard deviation. So the standard deviation is the square root of n times p times 1 minus p. And we're not going to keep writing these formulas. So this is the square root of 8 times 0.2 times 0.8. And that'll give you 1.1314. And keep in mind these do have units. So this is makes. And this is makes, as in making a free throw. Okay? All right, so that's pretty well done. So let's go back here. And what we're going to do is we're going to go back into this tab, which is going to be Control and arrow left. And we're going to change this from 0.2 probability to 0.5. So just go up and then hit Enter. And then we can edit. So you can see it both places, up and top. You can see the whole thing here. And we're just going to right arrow, right arrow, right arrow, past that 2, and then go back and delete it and just put in a 5. Hit Enter, and hit Enter again because we do want to overwrite. And let's see what we get for this, all right? Because it should already have changed the histogram. So control and arrow right. And look, it's symmetric. So we can put that in. All right, so that'll be symmetric. And 0.5 probability will make these things symmetric. All right, and mu is n times p again. So mu here is going to be 8 times 0.5, which is 4. And we'll go back and look at the histogram in a second. So the standard deviation is the square root of 8 times 0.5 for success times 0.5 for failure. They have to add up to 1. And that'll give you 1.41421. And these are both makes. Mustn't forget the units. So if this is going to be, if the average of this, the mean is going to be 4, then this guy should be centered. And remember, the 4 would typically be in the middle of this, not to either side. It's right here at the tallest part, and that makes perfect sense. Okay? So this is rolling along quickly now. So let's go back here. And, well, actually, let's stay here and go back to the spreadsheet. So control arrow right. And we want to change this now to 0.8. So go up, hit enter, and we'll just scoot over to the right until we go past the 5, delete it back the other way, and add in an 8, enter, enter. And if you probably guessed that that last one is going to be skewed to the left, you would be right. Do you see how the 0 starts out really small and it gets bigger and bigger and bigger and bigger? Well, if we look at the histogram, that should be skewed to the right. And so let's go ahead, I'm sorry, skewed left, not right. So let's say skewed to the left. By the way, I do have all of these done and up online. If you want to just do it, that's up to you. Some people will. So the mean for this is going to be 8 times 0.8. Well, 8 times 8 is 64. If you throw a decimal in there, it's 6.4, right? Makes. And sigma is going to be, strangely enough, it'll be 8 times 0.8 times 0.2, which if you look at this, isn't that really the same thing? Since, you know, it's all multiplication, it's commutative. This should give you the exact same standard deviation as what we had before. So it's 1.1314 makes. And if you look at these numbers, the middle one is the biggest, the one that's at 50%, and that's where your spread will be biggest. So biggest spread is always at 50%, and then it'll just drop off to either side. All right? And when you go back and look at this guy, it does seem to be more spread out than when it was symmetric because the tail. But keep in mind there's like hardly any probability out here. Most of it is packed into the, you know, the right-hand side here. So that's why you see a smaller standard deviation, smaller spread than when things are symmetric. So there's that. All right, so let's just go back and see if we need to fill in everything. I think we've got pretty much everything we need here. So we're going to write out the formula for calculating the probabilities using that one formula that we had for PDF. And we're going to have the same situation, a free throw shooter shooting 8, making exactly 5, assuming an 80% success rate. So if you want, we can just say n is 8, p is going to be 0.8, and let's say k is going to be 5. All right? So this is the probability. Oh, that's not a p, that's an r. All right, so let's fix that. Probability that, let's say x is 5. So maybe that should have been an x, but it doesn't really matter. All right, this will be 8 things taken 5 at a time times your probability of success, that's 0.8, raised to this power, to the 5th power, times the probability of failure, that's going to be 1 minus 0.8, and it's going to be raised to the difference of those two. You can write a 3 or just put 8 minus 3. And we can do that in the calculator. So let's go for it. Now I'm just going to go to the home screen and open up a scratch pad. There it is. Why not? It's just a simple calculation. And we need to start with those combinations. So if you've forgotten, remember it's menu and probability and combinations. So we want 8 things, comma, taken 5 at a time. Oh, it fell outside of those parentheses. That's not right. Okay, more live TV here, so bear with me. Get this back up here. Okay, I wonder why it went off of there. All right, so 8, comma 5. All right, now we can scoot out of here and say it's times 0.8 caret 5. And we can scoot out of the exponent level, times, and we'll just write it out the full way, 1 minus 0.8, which is 0.2 if you'd rather, and that'll be raised to the 8 minus 5 power. And if you hit enter, this is what it should be. It's always a good thing to check it doing a regular binomial PDF. So menu, probability, distributions, binomial PDF. All right, that's 8. Probability of success is 0.8. And x is going to be 5. And let's see if it's the same. Ah, it is. So good formula. So 0.1468 will wrap up our notes. And so there it is. Okay? So this is actually page 3, so ignore that. And I'm just going to leave you with page 4. All of this is posted. So if you want to put in your histograms rather than just rely on what you remember from the calculator, that's certainly up to you. But definitely remember this, and I hope that you found the calculator part of it interesting. That's all we covered. So I let them work the rest of the period, and we're just going to go ahead and close out. 2 more days until break. I think we can make this.